Hey there, so tonight I'm talking about this question 567, permutation in string. We have two strings, S1 and S2. We need to write a function to determine whether S2 contains a permutation of the first string S1. So in the form of a substring. So we have a continuously chunk of characters that's a random shuffle of the characters in S1. As an example, the first string is AB, the second string is EIDBAOOO, then BA is a random shuffle of AB, which basically means one of the possible permutation of S1. And because it's continuous, there are no other characters jammed in between, we return true. The second example, it's pretty much the same strings, except that now one of the O's in the towards the right is moved in between B and A. Then we don't have a substring of length 2, that's a random shuffle of A and B. So in the second example, we should return false. So it's a pretty standard sliding window question. So what we need to do is to based on the first string S1, we summarize the requirements. That's going to be the length of the string, the number of unique characters in there, what are they, and how many times each of those unique letters appeared in S1. So the frequency count for the individual letters. So we can summarize that in those terms, and then we maintain a window inside the second string, which is the window size is going to be the same length as the first string, and what we want to keep track of inside that window is the frequency count for the required characters that we gathered from S1. Whenever we have a window that matches the frequency count, according to the reference S1 there, the one that we generated, we can return true. Otherwise, we should return false. So it's a pretty standard sliding window question on strings. One thing that I think I made a mistake when I first coded this up is that I maintain a window, and when every time that I move the window, I doing a comparison with that frequency count I get from S1 by doing literally the key value pair comparison, full key value pair comparison. So that's a little bit wasty. So the time complexity for that is going to be the length of the second string multiplied by the number of unique characters in S1, because in each iteration I'm doing a hash map comparison. That's what exactly I did for 438, which I just unfortunately made a video about without noticing that. In today, it's pretty much the same question really compared to 438, but I'm gonna try to fix that issue in my actual coding here. And I noticed that when I was reviewing this question 67, minimum window substring, which I also made a video about, in that video I'm not comparing the key value pairs, rather I'm using a variable to keep track of the number of variables, number of characters I need to match the frequency. So in this question 567, we're just going to maintain a window with the same size as the S1, sliding it over towards right, towards the end. Every time we have a new character incoming, we try to update its frequency count, and we also decrement the outgoing characters. After the updates, we try to, instead of comparing the key value pairs values of the window, between the window and the requirement, we're going to use a variable to keep track of that. So it will become true linear with respect to the length of S1 and S2 added together. So that's why I'm revisiting this question. For a very long time, I think my solution to this, by checking the hash maps between window and the requirements, is going to be optimal. But looking at the question one more time, I find it's not. So let's just solve this question today. One thing that we can handle here is if it's the first string is actually shorter than the second one, actually longer than the second string, then there's no way we can have a substring in S2 that we don't even have a substring in S2 that's as long as S1, so we can return false. Otherwise, we can gather the requirement, and what we're gonna do is to construct the first window, and there will be a for loop to slide the window over. If we couldn't find anything, we can return false in the end. Otherwise, we will be returned early inside the for loop. The requirement is basically the length of the string and a frequency count for the characters. Let's call it the required char frequency. It's too long. Required frequency, which is going to be running a counter on the first string. It's pretty much just a hash map, empty hash map for each character in S1. We insert or we update the frequency count by 1. This is just a little bit shorter, but without using that, it will be one line as well for character in S1. The hash map get the key default 0 plus 1, so it's still one line. Yeah, so we can. It's not necessary to change this, I guess. You get the idea. The very first window is also a frequency count, but instead of S1, we are looking at the first n character from S2. One optimization, slight optimization we can do is to only keep track of the character frequency that we actually ultimately care about inside the window. If the requirement is the frequency count about character A and B, when we see E, I, D, those non-relevant characters, we don't even bother to put that into the window. So we can just filter those out. So this is by filter the first n characters in S2 based on only keep those that's in the requirements. Otherwise, we don't really keep track of their frequency. So then we initialize this to match requirement. It's gonna be our one variable that's telling us when we have a matching window between the window and the required frequency. Initially, it's the number of unique characters in the requirement and we're just gonna do a very first check manually. Later on, we don't do this. It's gonna be decremented by the exact match between these two in the beginning. So for every character in the requirements, if the first window matches the requirement in terms of their frequency count, we can decrease the number of characters we need to match by exactly 1. So that's what this line here says. If the first window it just so happened to be the perfect match, then we can already terminate the program. Otherwise, we'll go into the for loop. So that's the requirement gathering, the first window. Then it's the sliding window part. So when we deal with a window of the same size as the first string, when we try to move it towards right, we will introduce one of the letter from the right, and we will discard one of the letter that's leftmost inside the window. We're just gonna zip them all together, call them in character and out characters. So that's we'll pick up from here. That's the incoming one, and the outgoing one is from the beginning of S2. So since that the window only keeps track of those characters we care about, if either incoming character or the discarded character are not something we care about, we don't need to care about those. So we just check real quickly whether they are something we care about. We will update the frequency count in the window, and as well as to maintain this toMatch variable. That's the single one thing that tells us whether we have a matching window between the current window. The current window is a perfect match for the requirement. So let's see if I copy this over here. So after the update, we should be able to tell whether we have a match or not. So the logic in here is that we definitely would want to increment the character frequency count if it's an incoming one, and decrease the one if it's the one that we discarded. To update these toMatch, there are two cases. So if the current character frequency count inside the window is exactly what we wanted already, then by introduce this new character here, by adding another extra, we're gonna violate these two will become no longer equal. So we should actually increment this. The other situation is that so many extra space in there. The other case is that if we are just a one shot, so by adding one we can become equal, then we actually decrease this toMatch by one. So that's for the incoming part. For the outgoing, it's pretty much the same story, slightly different. Instead of checking, of course, instead of checking the incoming characters, we care about, we'll look at the outgoing characters. If we have a perfect match right now, by throwing that character out, we will have to increase this toMatch. If we have one extra, if we are just one more than the requirement, by throwing this character out, we can decrease this. So the logic here is it's pretty much the same, except that we are just the key is just different. You know, the increment and decrement, the testing condition is pretty much the same. So oh no, sorry, it's not. So this means that we have one more than the requirement. If I actually throw it out, I will become a perfect match. So I gotta be careful. So yeah, so this is pretty much the code. The time here, you can see we have one pass through S1, one pass through the first N character, then one pass through the rest of the N character, so it's one pass for S2 as well. For each iteration here, we have constant operation. It's a strictly constant operation. So while in the old code for 438, I'm actually doing the two key hash map comparisons. That's a little bit wasty. So I can I will actually go about and update my code for this and update the code on GitHub. So that's the question for today. try to review question. You might notice something new. So every now and then. Yeah. So that's the question for today.